LMJ Engineering is proud to present the civil engineering design for the Mount Ridgeview Drainage Project.
Hello, my name is Milton Escorcia. This presentation focuses on the Mount Ridgeview Drainage Improvements Project located in Ramona, California. The purpose of this project is to address ongoing issues with aging storm drain infrastructure, erosion, and roadway damage that are impacting safety and long-term performance. Our team was tasked with developing a comprehensive engineering solution that includes upgrading the existing storm drain system, improving drainage through soil reconstruction, and repairing roadway sections affected by poor runoff management. In addition, the project includes the development of a building pad for future use, which requires proper grading and site preparation while ensuring it integrates with overall drainage design. Throughout this presentation, we will walk through our approach and supporting analysis that guide our final design.
LMJ Engineering is composed of highly qualified engineers prepared to address drainage projects just such as this. Led by Justin Gibb, our team developed key deliverables including the basis of design, geotechnical and drainage studies, stormwater management plan, structural calculations, and the engineer's estimate. These components were evaluated using the Envision pre-assessment checklist and integrated into our final plans and drawings to deliver a complete and coordinated design solution.
Malukas Techs developed the geotechnical report, which includes recommendations for foundations, retaining walls, pavement design, soil mitigation, and buried capacity. The analysis was based on laboratory and boring log data and conducted in accordance with ASTM standards, the Caltrans Geotechnical Manual, and the 2025 California Building Code, using standard design assumptions for site conditions. This geotechnical investigation evaluates subsurface conditions at the project site through geologic mapping and laboratory testing. The geologic map indicates the site is primarily underlain by granitic rock, which provides a relatively strong and competent foundation material but may vary in strength depending on the degree of weathering and fracturing. To further assess soil behavior, direct shear tests were conducted on representative samples of the weathered granitic material. The results provide key shear strength parameters, including cohesion and internal frictional angle, which provide us with essential information for evaluating stability and design loads. Overall, the subsurface conditions provide a strong basis for long-term stability and performance.
Lene Leininger and Julia Baxter have prepared the drainage study to summarize the engineering approach, assumptions, and design criteria used to evaluate the drainage conditions at the project site. The scope includes both hydrologic and hydraulic conditions under the existing and proposed conditions based on a 100-year storm event. This project was designed in compliance with several key standards, including the City of San Diego Drainage Design Manual and Hydrology Manual, and the San Diego County Hydraulic Design Manual. To study the initial capacity of the system, watersheds were first delineated using ArcGIS. Then runoff was calculated using SANDAG, land use, and soil type data layers. For this site, the major soil type group is hydrologic soil type D, meaning that the soil has slow infiltration rate and high runoff potential. Land use assumptions were based on residential designations. The before grading condition coefficient of runoff was calculated, averaging watershed 4 and 5 for storm drain pipe 4. In this image, flow and velocity were calculated using Manning's equation. For all calculations, the minimum slope of 0.5% was used. For the proposed analysis, the grading and an 100 storm event would impact the existing infrastructure to see if it was undersized. We used the rational method to estimate peak runoff, assuming a minimum time concentration of 5 minutes. Rainfall intensities were taken from the County of San Diego isopluvial and IDF curves. With the proposed development adding 1.06 acres of graded area and about 70% impervious surface, runoff increases, raising the runoff coefficient for storm drains 3 and 4. As shown, the system is undersized for storm drain pipes 1 through 3. Pipe 1 should increase from 12 to 18 inches, Pipe 2 from 18 to 30 inches, and Pipe 3 from 24 to 30 inches. Pipe 4 should be replaced with a 24-inch pipe due to structural failure. Reinforced concrete pipe is the chosen material due to its durability.
Utilizing the runoff flow rate from the proposed conditions that accounts for the new impervious surfaces, a swale alongside Ridgeview Road was designed. The design works with the existing topography and storm drain pipe locations to channel runoff towards low points at the pipe inlets. The swale itself is lined with number 2 riprap backing and native plants along the bottom of the swale.
Ramona, California is low risk due to its rural setting, so basic erosion and stormwater controls are sufficient. LMJ Engineering recommends adding drought-tolerant native plants like deergrass and blue-eyed grass to the swale, which will help slow down runoff and naturally filter out sediment and pollutants when it rains. Riprap will be implemented in the swale as well as the outlet and inlet of each pipe. Using the Institute of Sustainable Infrastructure and Vision System, the project is on track for a silver award highlighting its sustainability, resilience, and community benefits.
Maber Manu prepared the structural calculations package to summarize the design approach, assumptions, and criteria for evaluating the proposed drainage and structural improvements. The scope includes analysis of culverts, head walls, outlet stabilization, a brow ditch system, and retaining walls. The project was designed in accordance with applicable ASTM and County of San Diego standards, including the regional standards and hydraulic design manual. 4 proposed RCP culverts were evaluating using this design criteria. The required loads range from 550 to 917 pounds per foot, which is well below the Class 4 capacity of 2,000, confirming all culverts are structurally adequate. 4 head walls were analyzed, including straight head walls for culverts 1 and 3, an L-shaped return wall for culvert 2, and a constrained head wall for culvert 4. Stability checks show sliding factors of safety and overturning well exceeding the 1.5 requirement. Maximum bearing is about 932 psf, which is below the 2000 psf allowable, making all head walls stable. The brow ditch is designed as a concrete-lined Type D ditch, about 30 feet long with a 1.5 foot depth and 4.5 foot top width. It conveys a design flow well below its capacity at 34.66 CFS, with erosion measures in place to slow flow velocity. Retaining walls were designed using the standard Type 1 system, with heights considered up to 18 feet. Surface drainage is controlled using a concrete-lined brow ditch at the top of the slope to intercept runoff and reduce hydrostatic pressure with exceeding stability requirements, confirming a safe design.
Justin Gibb prepared this engineer's estimate to summarize the construction costs associated with the proposed drainage and site improvements for the Mount Ridgeview drainage project. The estimate includes itemized costs for storm drain installation, swale and channel reconstruction, roadway restoration, retaining walls, and site grading based on calculated quantities and unit pricing. Unit costs were developed using regional standards, including the Caltrans contract cost data, the San Diego County unit price list, and the City of Del Mar bonding cost data to reflect local construction conditions. This slide summarizes the total estimated construction cost, which is approximately $1.81 million, including a 20% contingency to account for uncertainties. The largest cost contributors are retaining walls and pad improvements, followed by earthwork and roadway restoration, primarily due to grading requirements, wall heights, and material movement across the site. Storm drain improvements and swale reconstruction make up a smaller portion of the cost but remain critical to the overall system performance.
Overall, the existing drainage system was undersized and led to flooding and erosion issues. The proposed design upgrades the roads and culverts, adds head walls, swales, a brow ditch, pad developments, and retaining walls, and is designed for the 100-year storm event. Combined analyses confirm the system is hydraulically efficient, structurally stable, and constructible. In conclusion, this provides a cost-effective and long-term solution for improving drainage and roadway performance.
Thank you.